Here the question is, in Dumas method for estimation of nitrogen, 0.25 gram of an organic compound is producing 40 ml of nitrogen gas, which is collected at a temperature 300 Kelvin and a pressure 725 mm of mercury. We need to find out the percentage of nitrogen in the organic compound, and it is also given that the aqueous tension at a temperature 300 Kelvin for nitrogen gas is 25 mm of mercury. First of all, we need to find out the actual pressure of the nitrogen gas. The volume of nitrogen gas collected is 40 ml. The aqueous tension at a temperature 300 is given as 25 mm of mercury. So the actual pressure will be 725 minus 25, that is 700 mm of mercury. Now we can calculate the volume of nitrogen at standard temperature and pressure, that is equal to 273 multiplied by 700 multiplied by the volume of nitrogen 40 divided by the temperature and pressure 300 into 760, and we will get the answer, that is equal to 33.52 milliliter. Now we know that the molar volume for nitrogen gas is 22.4 liter or 22,400 milliliter. 1 mole of nitrogen has the weight 28 grams. So we can write the mass of 22,400 ml of nitrogen gas at STP is 28 gram. Now we can write the mass of 33.5 ml of nitrogen, that is equal to 28 into 33.52 divided by 22,400 multiplied by 0.25. From this, we can calculate the percentage of nitrogen in the compound, that is equal to the mass multiplied by 100, that is equal to 16.76%. So from these options, the correct answer is option B.